Homework 1.6, other types of equations, video 5. Homework due May 16th, 2020 at 11:59 p.m. Quadratic-like equations, also known as substitution, part 1. Before we read the part in green, let's take a look at this equation. Solve x to the 4th power minus 34x to the 2nd power plus 225 is equal to 0. Is this a quadratic equation? No. Because even though it has an x squared, by definition, a quadratic equation has a highest power of x squared. This power is higher than x squared. So technically, we can't do things to it like we do to quadratic equations. I have to get some more water after this video. But we can trick it into thinking it's a quadratic equation temporarily. How do we know when we can do this, and when we can't, how do we pull it off? Well, the when is easy to explain. If an equation has two terms with matching bases, a base is a part that has a power on it. So in x to the 4th, 4 is the power, but x is the base. If an equation has two terms with matching bases, but one power is twice the other. These two terms have matching bases. The base here is x, the base here is x. One power is twice the other. If that is present, then you can pull off what's called a substitution, and then it will expose why this is a quadratic-like equation. It's like a quadratic equation, but it's not technically one. So, if you have two terms with matching bases, but one power is twice the other, here's what you can do. We're going to make what's called a substitution. A substitution is where you rename something with a nickname, and it's usually temporary. What substitution are we going to use? We're going to bring another letter into play. Now, any letter will work besides the one that's already being used. But in the homework, when it asks you what substitution you're going to use, it's going to expect you to use the letter U. That's actually the same letter that's used in calculus substitutions, but let's not worry about that. So in the first step, you let U equal the lesser of the two powers, and U squared equal the greater of the two powers. And this isn't just some magic, something you can wave your hands and do smoke and mirrors and say, see, it works. But here's the idea behind a substitution. We're going to let U be the smaller powered term, not the 34x squared, but just the x squared. Now, why do we get to say U squared equals the greater of the two powers? Because if we arbitrarily decide to give this x squared a nickname, hey, U, then watch what happens if we square both sides of this equation. We get U squared equals x squared squared. And there's an exponent rule that says when you raise a power to a power, you multiply them. 2 times 2 is 4. That's why it's important for one power to be twice the other. So that when you square both sides of this substitution, that power gets doubled and matches the other one. So I'm going to rewrite this equation based off of this substitution. So x to the 4th is going to get replaced with U squared. X squared is going to be replaced with U. And then everything else stays the same. So although it wasn't originally a quadratic equation, because of the structure of the problem, two terms with matching bases, one power is twice the other, you can pull off a substitution by renaming the lesser of the two powers a single letter, like U. Then the larger of the two powers becomes U squared, and now it's quadratic. And we can solve it as such. So let's solve this new equation with EU. In order to solve this, what's a quadratic equation now? It was quadratic-like, now it's true quadratic. Highest power is 2. We could solve it by factoring, we could solve it using the quadratic formula. Now in my mind, I've been racking my brain figuring out what two numbers will factor this, but I can hear some of you screaming at the screen right now, but you made a mistake. I just noticed it. This was 225, and when I went down here, it suddenly became 255. Crisis averted, but not quite, because I don't know what this factors into, which really bothers me, because I usually take pride in being able to look at a trinomial and factor it fairly quickly. This one I'm having trouble factoring, but I think it's, oh, I got it. Again, you can get out the quadratic formula, but to me, this looks like $2.25, which is 9 quarters. 225 is 9 times 25, which is really convenient because 9 plus 25 is 34. So you could use the quadratic formula. I'm going to go ahead and push this by factoring. The two numbers I believe I need are -9 and -25. They do add to give 34, excuse me, -34. Negative times negative is positive, and 9 quarters is $2.25. Hey, this is easy to solve. If I put u minus 9 equal to 0, I get u equals 9. And if I put u minus 25 equal to 0, I get u equals 25. Hooray, we're done, except we're not. Because we weren't solving for u, we were solving for x. I mentioned that substitutions are temporary. Thank you, u. I appreciate you going in, transforming this into something that I can solve, and helping me solve it. Now, get out. I need to know what x equals, not u. U is temporarily holding the place of x squared. So guess what's going to go back in now? Out with the u and in with the x squared. Substitutions are temporary. So the u goes back to being an x squared. It's right up here. So we have x squared is equal to 9 and x squared is equal to 25. But both of these little bitty quadratic equations are easy to solve. I just have to hit both sides with the square root, and don't forget the plus minus. So plus minus 3, plus minus 5, and now we have all 4 solutions. I glanced over here and realized I started a flow chart, if you will, a how-to list, and didn't finish it. So let's see if we can finish this. Let u equal the lesser of the 2 powers and u squared equal the greater of the 2 powers. Solve the quadratic equation, because it will be quadratic at this point. Solve the quadratic equation. Change u back to what it equals. Parentheses in the substitution. And the reason I put that parenthetical follow-up in the substitution is because at the bottom of this it said u equals 9. So you want me to change u back to 9? No. I want you to change it back to what it equaled in the substitution. And then finish solving. You don't have to check solutions here unless you're solving a square root equation. And it could very well be a square root equation that we're solving at the end, in which case you would have to check solutions. All right, so we'll do another one here in a minute. But before I forget, this is similar to question number, I want to say number 9 in the homework. But at the conclusion of not this video, but the next one, you should try homework 1.6, numbers 9, 10, 11, and 12. I believe 9 and 10 are like this one. 11 and 12 will be like the next example.